Hello dear friends, I hope you all are doing well. Welcome to session 14 of ARC BIM course. As you're concerned, we have done and completed the reinforcing armatures of the slab, or the first level actually. And as you can see, reinforcing beams is done. In the continuation, we're gonna add some beams and also some panels to complete the floor, adding molds, assigning phases, and then concrete casting and reinforcing armatures, like this way. We don't have the family of concrete joist in the default families of Revit, since they are being used in some of the projects in some of the Asian countries, and they are used instead of slabs. Firstly, let me show you an image. Look at this. So in the continuation, we want to model one of them and then use it as a type. As you can see, it includes expanded polystyrene as well, or styrofoam that is placed on the concrete joists. And in the continuation, I want to tell you how to model these step by step together. For now, I want to brush aside the whole project, and then I want to open a new family template file in a structure, metric structural framing beam and braces. I double click on it to open it. Here, as you can see, there are some parameters here and also some reference planes that we can control the values. The length, which is the total length of the beam. I can remove the redundant items here, but I do not delete the left reference planes. Here, if I pick extrusion and draw a rectangle like this way, I can lock them to the reference planes, and then when I load it into the project, watch this, I can place it here, and if I pick the shape handles and control the length, we are modifying the total length of the beam parametrically. And these shape handles are used when we want to add cutbacks. So note that this is the difference between these two types of reference planes. But if I align these two reference planes with each other, check this out, and lock them, then I load it into the project and override the changes. Watch this. Here, as you can see, the length can be modified manually. But let me find this parameter, which is extension, start and extension. Anyway, let us get back to the family environment and then model the beam. Firstly, if I open left view or right, doesn't make difference. Let me set the project units by this way. Afterwards, I want to add two reference planes, and I want to use these for controlling the thickness. Afterwards, I add the dimensions. Let me add the aligned measurements, 1 to 5 scale, equalized, and then adding the dimension values by this way. I use the left one to control the height of the beam. Afterwards, it's time to associate the parameters. Instance, then renaming it, width of the base of the beam. I copy the name. Afterwards, I want to associate the another parameter, concrete base height, for the name of our new parameter, instance, and OK. Afterwards, based on the given information, we can specify the values of each dimension. For instance, 25 for width and 7 centimeters for height. Then I want to draw an extrusion Let me add a work plane, reference plane left, and then I draw a rectangle and I lock the sides. Then I pick the shape handle and then I lock it to the reference planes by this way and lock. Afterwards, let me see, let me zoom in and lock. Then using align, checking lock, multiple alignment, well done. Then if I move them, as you can see, the length is changing very well. Then here, as you can see, we got two reference planes. The main reference plane controls the total length of the beam, while the second one controls the cutback of the beam, or extension actually, start and end extension. Anyway, we're done with the rectangle. Afterwards, we're gonna model this image. There are the truss-like bars, as you can see. We can add the bars or rebars here in this family, but some of the truss-like rebars must be arrayed, so we cannot model them here. So to model them, I want to open a new family template file, generic model, in order to model the truss-like rebars. Here there are some openings, as you can see on the screen, that it depends to the bar diameter, the top bar diameter. So it changes based on the bar diameter to the top bar diameter. It means that this is not a fixed value, and we have to assign some parameters, so then we can change the value of diameter and also the length of the opening. And if you have multiple types of bars or multiple lengths of openings, you can create multiple types in order to apply them in your projects. Anyway, to model this, we can use strip, and as you can see, the rebars are placed inclined. So we need some inclined reference lines or reference planes in order to control the value of opening or the angle. So let us get back to Revit. Afterwards, I want to open one of the elevations like front or back. Let me see. If I want to draw the inclined reference line, then we should draw the path at left or right elevations. Or we can draw the path in front or back elevations and then draw the inclined reference lines in left or right view. First of all, let me set the project units per centimeters and OK. Well done. Then, first of all, let me open the 3D view by this way, and then opening front elevation. Let me hide the reference level, and I pick the model line. Firstly, I drew these inclined lines, but we'd better to start from left elevation, and then create reference plane. I draw these two vertically and then one horizontally like this way. Then I want to add the aligned measurements. Well done. And then these two middle ones. Great. And then for the height. Great. And I want to draw another reference plane horizontally like this way and adding 1 centimeter, and then I fix and lock the value. Following that, it's time to associate the parameters. Firstly, I want to associate the bottom width, instance and OK. And then the top part, top width instance, and I select this, equalize, and equalize for the bottom part as well. After that, I draw 2 reference lines more. I don't want to consider the primary reference plane, so I hide it. Again, I draw a reference plane and draw these 2 inclined lines. Lock and aligned. I press down tab and then I lock the point to the reference planes. I do the same thing for the bottom part as well. Let me adjust it. Let me delete it and draw it again. Watch this better. And let me align them and lock the points to the corners like this way. Great. And let me see if the another one is aligned as well. Okay. Then if I move these 2 reference planes, as you can see, and let me test the height. Well done. We can change it in 3 directions. And let me associate a parameter for height. Try to define proper names for the parameters. Then I pick the circle. Suppose that the board diameters is 8 or 10, so we consider the radius value, which is 4 or 5. Watch this, millimeters. Check it out. Suppose this as a armature, 1 centimeter diameter. Then if I reduce the opening, check it out, then the rebars must placed at there. I mean, if I select these lines and then I associate the parameter of top width, check this out. For instance, if I specify 1 for the top width, however, I should specify 0.5. I mean the diameter, not radius. Okay, diameter. Let me check it out, and then I associate it to top width, like this way. Then the other inclined rebars must be placed there. I mean, they must be stored from there. However, in order to avoid intersections, I can add 2 more reference planes in order to place the bar ends on the reference planes. So I draw the reference plane like this way. I add the line measurement, assigning the top width, and they should be equal to each other. Then if I unlock these points, watch this, and then I change the position of the point and lock again by this way. I replaced it and locked. So I moved in another one. As you can see, then I remove the constraints like this way. Afterwards, lock. Then let me place the point at the proper position, just at the intersection, and locked. Then as you can see, we can control it. So right now they are connected to each other, and if I move them upward, as you can see, they are parametric. Let me check constraints. Remove constraints, again remove, and then I select this one to associate it to top width. Very well. Then if I change them manually from family types 1.2 or 0.8, 0.6 or 20 or 2 centimeters. I set 1 centimeter or 10 millimeters. Here, as you can see, we got two inclined references that we want to draw the other geometries based on these two. And we move on from the front or back views. Still, we need two inclined reference lines, and I want to bend them as well. Let me add this aligned measurement and the dimensions. This is the length of the opening actually, but we're gonna consider the top part fixed, but we'll change the bottom part, okay? So selecting the dimension and then associated to double L length. Then as we want to draw some pipes or bars, I'm gonna use sweep. Then we sketch the path for the sweep. Then I start specifying the first point, move it upward, the second point, and then third point at the intersection of reference planes. Actually, here we haven't equalized both sides, I mean the dimensions. And then I should bend them as well. So if I add a fillet here, let me see. I can specify the radius value for the fillet like 1.5. Then let's check out the result. Watch this. Then it's time to lock the endpoints to the reference planes. Afterwards, watch this, connecting it to reference plane and lock it. Well done. Then select profile and then sketch profile, picking the circle by this way, and then measuring the diameter. I fix it and then I associate a tree parameter to control the diameter's bar's diameter actually. It is done. Let me equalize the both sides. Look, they are constrained to the reference planes and controlling the height. If I change the bar's diameter like 0.6 and then I apply it, watch this, this is the result. So here is one of the sides of the element, and moving back to left, front, and checking back, okay, checking left again. I have to open this a little bit. Right now I just understood that I have made a mistake that we should fix it, guys. We had to set our work plane to this gray line, okay? So we set the work plane again, and then let me see, set a plane, pick a plane in left. Let me check from the front view, pick a plane. I can fix it by this time. I have to remove it. Again, I should set the work plane. I set it on this line, then drawing the sweep from the intersection, and then continue the another inclined line or path. Then before locking it, I check radius and I import 1.5. Then it's time to lock the points or the endpoints with the reference planes. Adding the profile, drawing the circle. Right now we have referred it to the right reference plane. Adding diameter. Let me see. Align diameter 1 to 1. associating the value of bars diameter, and okay. So this is the opening that if I close it, check it out, and they are placed on the path or on the other pipe, as you can see. And also we have added the fillets to create the bends. Then I want to open back and then repeating the same process for the other side of the project by this way. I specify the first and the second points. Before aligning it, I check radius, adding fillet. But if we do not check radius and lock the endpoints of the line, let me show you the results. Then if I want to add the fillets, after locking the points, we'll have abnormal results. So please add the fillets before aligning the endpoints. After adding the fillets, it's time to align the endpoints to the intersection. Wait for a second to align the endpoints, 50 reference planes, finish the changes. Look, afterwards it's time to draw the sketch the profile, circle, adding the diameter, and then associate it to bars diameter. Okay, let me reduce the value of diameter, and then okay. Then if I open left view, we should fix the height. Let me check this. Something is wrong. Again, I get back to back elevation. Let me see what's wrong. Maybe it's because the moved point, but let me check it out. This is okay. 3D view, and let me check this out. Let me see what happens if I connect these 2 points to each other. It's okay. I want to draw it again. I think I realized the problem. Then again I want to draw a sweep. Let me zoom in by this way. And now as the profile changed, some problems just shown up. Anyway, let me draw the path by this way. Afterwards, and this part, the other side. But in order to reduce and avoid errors, let me select this and then hide it. Afterwards, from Create tab, Sweep, Sketch Path. Watch this. Let me choose the right point here by this way. Very well. And then the radius is predefined. Look, so they are accurately placed. Then let me align the points, 50 reference planes, like this way. Okay, to save the changes, finish. And then let me sketch the profile. Then adding the diameter and associating it to a parameter. Okay. Then let's see what we have done. Look, their heights are the same. Then we can change the width opening, and also we can change the height. And here, as you can see, the bar diameter is changing, and a change in bars diameter changes the sweep's positions, as you can see. I mean, as it increases, the lengths of the sweeps increase too. Anyway, we are done with this. Let's look at it in the 3D view. And of course, I can associate a material parameter type. I deleted that. I remove it for now, and then in the left view, let me tell you a point here in the left view. Of course, we have to move the reference plane. We can consider a fixed value for it. I mean, we have to specify a range for the bar's diameter. No, a limit, since it must not be increased so much. So after that, we're gonna have better results. So by this way, we can control the height of these two sweeps as well. And let me remove the constraints, Control Z, okay. And let me test this. I lock it, move it upward and moving it again downwards. And let me check the top width. We'd better to create a new parameter and then connect it to it. So if I remove these, then we can easily open and close it. Here in family types, top width, let me see. If I want to set 10 or 0.8, and then for height 25, look at this. Right now it fixed. It was because of the extrusion, but right now it is okay. I load it into the family template file, and then in the plan view I save the file as, I name it concrete joist and save. Following that, if I pick these reference planes, watch this, we need 2 more reference planes vertically, watch this, like this. And so guys, I want to take a break. We'll continue the process in the next session. I hope you enjoyed this session too. Take care, see you next session.